where is the question? Where is the reaction above? The reaction above is, this is the reaction. As reaction above. So the reaction above is talking about this reaction. So here, what's this one talking about? This is Gay-Lussac's law, because this is reaction of all gases. So automatically in this reaction, they now said what volume of hydrogen will be left over when 300 and 1000 of hydrogen are exploded in a sealed tube. What volume of hydrogen will be left? Now, if you look at this, the question is saying that you are given 300 cm3 of oxygen, then you have 1000 cm3 of hydrogen. Now, if you go by the ratio 2:1:2, this one is talking about Gay-Lussac's law, which is theory of all gases. So in this situation, if you have this, then you are going to have 300 cm3. If you are having 300 for one, automatically for two should be 600 in that. So if you have 2:1:2, if you are now having 300 of oxygen, then you should have 600 of hydrogen. So automatically when you go by this one nullifies this, and this one will also be what? 600 cm3, although the question did not ask us for this. So we have to pay attention to this. This minus this is 0. This minus this 400. That means the volume of hydrogen that will be left unreacted will definitely be 400 cm3. So we'll go to our option and see the one that will correlate with that. A, 200 cm3, B, 400 cm3, C, 600 cm3, then D, 700 cm3. So the one that will match that will definitely be B, which is 400 cm3. Now, question 6. 50 cm3 of a gas was collected over water at 10 degrees Celsius and 765 millimeter mercury at 765 millimeter mercury. Calculate the volume of the gas at STP, that's standard temperature pressure, if the saturated vapor pressure of gas at 10 degrees Celsius is 5 millimeter mercury. This one is testing no other thing other than what? Grant's law, no, Dalton's law of partial pressure. That's what it is testing. And remember that in that one, you are given a gas which is at 10 degrees Celsius, and at that 10 degrees Celsius is collected over water with what? The pressure becomes at this, which is 5 millimeter mercury. The original pressure is 765 millimeter mercury, but this is collected over water. So if you want to know the actual volume of this gas, it will definitely be, total pressure equals to P gas plus P water vapor. That's one of the law, one of the equation connecting these parameters. So in this situation, the total pressure here is 765 millimeter mercury, and the pressure of water vapor minus pressure of water water vapor is equals to the pressure of the gas, which is what we are looking for. So definitely it is 765 millimeter mercury minus what is the pressure of this gas? It is 5 millimeter mercury, which will now be pressure of the gas, which is P1. So it will definitely be what? 760 millimeter mercury. So here you have 760 millimeter mercury as the pressure of the gas. Okay? Now at STP, that is standard temperature pressure, we have P1 to be equals to 760 millimeter mercury. Then V1 to be equals to, what's our V1? our V1 is given as, we have 50 cm cube of a gas was collected over water at 10 degrees Celsius and 765 millimeter mercury. Calculate the volume of the gas at STP if the saturated vapor pressure at 10 degrees Celsius is 5 millimeter mercury. So in this situation, we have our T1 to be equals to 273 Kelvin. Then our V1 here is what we want to calculate. Meanwhile, we have our P2 to be also 760 millimeter mercury. Our V2 has been given in the question, that is 50 centimeter cube, while our T2 will definitely be 273 plus 10, because we have it in what? In degrees Celsius. And I said to convert to Kelvin, we need to add 273 to convert it to Kelvin. So in this situation, by applying P1 V1 over T1 equals to P2 V2 over T2, that is general gas law, then we have our interest to look for our V1. So P1 760 times V1 over 273 equals to P2 760 also times V2 50 over 283. This one is then going to be 283 Kelvin. So now we are looking for V1. So V1 will definitely be 273 times 760 times 50 divided by 760 times 283. So we have V1 to be equals to 273 times 760 times 50 divided by 760 times 283. This 760 can cancel this. And let's use our mathematical instrument to fashion out that calculation. So 273 times 50 divided by 283. That's 48.23. So we have 48.23 centimeter cube. So we'll go to our option and check the one that will definitely correlate to that. So in the first one, we have 49.19 centimeter cube, 48.87 centimeter cube, 48.55 centimeter cube. Then we have D, 48.23 centimeter cube. So the answer will definitely be D, that is 48.23 centimeter cube. Question 7, which says that what volume of carbon dioxide is produced by reacting excess carbon with 10 dm³ of oxygen. So we are having carbon dioxide as a product. Before you can have carbon dioxide as a product, automatically this is a gas. It will be coming from carbon and limited oxygen. So if you are having carbon and limited oxygen, that's solid gas, then you have this. So you can see how carbon dioxide is produced. So you have 2:1:2. That's the idea. So this is also testing what? Gay-Lussac's law of combining volume. So in this situation, if you look at this, it's talking about oxygen and carbon dioxide. Now, let's check their mole ratio. 1 mole of oxygen gas is equivalent to what? 2 moles. 2 moles of carbon dioxide. Then that means 1 dm³ of oxygen will definitely be equal to 2 dm³ of carbon. I'm basing this on their mole ratio. Now, if we now have 10 dm³ of oxygen, so definitely to be equivalent to 2 times 10 everything in dm³ of CO. That's by their mole ratio. Then at the end, we're going to have 20 dm³ of CO. What it means is that 10 dm³ of oxygen is required to produce 20 dm³ of carbon dioxide. So we'll go to our option and check the one that will correlate to that. That will definitely be 20 dm³. That is option D. So the next question says that the rate of diffusion of gas Y is twice that of Z. So we also have gas Z. We also have what? Gas Z. So that means, and the rate of diffusion of gas Z is this. So if I want to relate that mathematically, the rate of diffusion of Y is 2 times that of Z. That's what they are telling us. Now, in this situation, if the relative molecular mass of Y is 64, My is 64, they gave us relative molecular mass of, then let's talk about relative molecular mass of Z. So in this situation, it's talking about what? Grant's law of diffusion, which states that the rate of diffusion of a gas is inversely proportional to the square root of density. So if it is proportional to the square root of density, definitely it will also be proportional to the square root of what? Relative molecular mass, because there is a relationship between density and relative molecular. And at this point, it is pertinent to note that relative molecular mass is 2 times vapor density. That means they have what? A direct relationship. Although relative molecular mass is bigger than vapor density. Take note of that. So at this point, since I have rate is inversely proportional to square root of relative molecular mass, what it means is that if I'm relating gas Z and Y, what it simply means is that I will write my relative molecular, so rate of diffusion of Y over rate